All right, so here's a concept that a lot of people can have problems with, but I want to make it as straightforward as possible. Square roots, as well as other roots, so cube roots, 4 roots, 5 roots, all the roots. But I want to show you a real simple, not a, it's simple. You just need to write stuff down. It's always about just writing stuff down. There's ways to do it, but what makes people good or not is whether or not they take the time to write everything down. Because when you write it down, it's real easy to see what's what. So let's take a look at some examples. Okay, so we know how to do, well, I would presume we know how to do square roots for whole numbers. When we take a square root of 25, we know that that's 5 because 5 times 5 equals 25. That's what the square root means. In English, it means what number multiplied by itself twice equals 25. Just like when we see 5 squared, the English question is 5 multiplied by itself twice. Inversely, the square root says what number multiplied by itself equals 25. So the square root is the inverse of squaring a number. 5 squared equals 25, square root of 25 equals 5, okay? So when we get to 144, the square root of 144 asks what number multiplied by itself twice equals 144, and that's going to equal 12. 12 times 12 equals 144. And then same thing over here with x. What number multiplied by itself twice gives you x squared? That's going to be x times x, okay? Real simple. There's also different roots. For example, we could have the cube root indicated by a little 3 here, and it asks what number multiplied by itself 3 times equals 8. Well, I can tell you that's going to be 2 times 2 times 2 equals 8. And then another one we could have is 64. What number multiplied by itself 3 times equals 64? Well, that's going to be 4. 4 times 4 times 4 equals 64, okay? And then let's use a y cube over here. What number multiplied by itself 3 times gives us y cubed? Y times y times y. Okay, simple enough, but things can get more complicated quick, so this is how we want to break it down. So let's forget that we know the answers to all of these. All right, so what we want to do is we want to make a factor tree. Factor trees are way more useful than they get credit for in normal math classes. So let's break this 25 down into its factors. 25 is 5 times 5. And something to note, when you see a square root sign without any number here, it's always assumed to be 2. So it wouldn't be a bad idea to just make that a habit of writing 2 there, just like we write 3 for a cube root. 2 is right here. Okay, so because it is the cube or the square root right here, if we see a number in here twice, we can cancel it and pull it outside. So 5 is in there twice, so we can pull that out. There's nothing left in the square root sign, which just means 5 was our answer. Let's take a look at this over here. Let's do a factor tree of 144 because this one's a little bit bigger. So I'll do the full factor tree for you. 144 can break down into 12 and 12. It can break down into 6 and 2, and 3 and 4, 2, 3, 2, 2. So we can put down all the factors inside here. We got a 2, a 2, a 3, and a 2, a 2, a 3. So 2, 2, 3, 2, 2, 3. And because we're taking the square root, we want to find everything that shows up twice and pull it outside. So we got 2 2s, we got a 2 out here. We got 2 3s, we got a 3 out here. We got 2 2s, we got a 2 out here. 2 times 3 is 6, times 2 is 12. So that's how we know the square root of 144 is 12. Now, this may seem like a lot of extra because obviously we already knew that it equaled 12, but it's important to set up these foundations because things are going to get more complicated quick. So you can't just rely on knowing it off the top of your head. You want to be able to know how to do it the proper way. And then lastly over here, x squared is the same as x times x. Because it's the square root, everything that shows up twice can get pulled out. So x is our square root. Now let's take a look at these over here. 8 breaks down into 4 and 2. 4 is 2 and 2. So underneath we call this sign the radical. So underneath the radical, we have 2 times 2 times 2. And because it's the cube root, everything that shows up 3 times 1, 2, 3. Pull out the 2. There's nothing left. 2 is our answer. 64. 64 is the same as 8 times 8. And 8 times 8, what we just saw from here, is 2 times 2 times 2. 2 times 2 times 2. All right, so underneath the radical, we have 2 times 2 times 2 times 2 times 2 times 2. Because it's the cube root, everything that shows up 3 times. 1, 2, 3. 1, 2, 3. And we can multiply them. 2 times 2 is 4. That is our cube root of 64. And then y is the same as y times y times y. That goes under the radical. Y times y times y. Everything that shows up 3 times can get brought out. Y is our cube root of y cubed. All right? All right, let's take a look at some more complicated examples here. So there's no number here, which means it's the square root. So let's make our factor tree. We can break this up into 16 and then a6, b4. And that just tells, and 16 is going to be 4 times 4, which is going to be 2 and 2 and 2 and 2. And then this just means there's 6 a's and 4 b's. So let's just go ahead and write all that out. We want to so just write everything out. There's nothing wrong with writing everything out. 2 times 2 times 2 times 2, and then 6 a's. These are all being multiplied, of course, and then 4 b's. All right, and then the square root tells us everything that shows up twice can be pulled out. There's 2 2's, there's 2 2's, there's 2 a's, there's 2 a's, there's 2 a's, there's 2 b's, there's 2 b's. All right, 2 times 2 is 4, a times a times a is a cubed, b times b is b squared. So this tells us that the square root of this whole thing is going to be this right here, and we can test that because if we multiply 4a cubed b squared by 4a cubed b squared, 4 times 4 is 16, a cubed times a cubed is a6, b squared times b squared is b4, so it checks out. Now let's see what happens if it's not a nice round number that comes out. So let's take the cube root of the number we just worked with, 16a6b4, okay? Well, actually, let me start. No, we'll go with this. So, yeah, we'll do one of each. So, let's just break it into the factors. We already know what all those are, so I'll just go ahead and rewrite everything. That's going to be 2 times 2 times 2. Okay, so it's the cube root, so everything that shows up 3 times gets pulled out. 1, 2, 3. We got a 2. We got an A. We've got another A. And we've got a B. All right, so notice this time there's still some items left over under the radical, okay? We got a 2 and we've got a B. So that actually just gets rewritten under the radical again, okay? So the cube root of 2b. And then we can combine everything else. 2a squared b times the cube root of 2b. And the reason this stays like this is because there's no way to simplify that any further, so it just has to stay there being multiplied, all right? Let's take a look at a whole number example. Let's take the square root of 125. First, we want to break it into the factors. This is the same as 25 times 5. 25 is 5 times 5. So that means we have the square root of 5 times 5 times 5. Square root means everything that shows up twice, just a 5, but we have a 5 left over under the square root, so we can keep that. So the square root of 125 is 5 times the square root of 5. Now, remember, square root means what multiplied by itself twice gives us 125. So let's see what happens if we multiply 5 to the square root of 5 times 5 square root of 5. Well, 5 times 5 is 25, and then square root of 5 times the square root of 5, that's the same as just multiplying both these numbers underneath the radical. So this is the same as writing, can you still see? Yeah, this is the same as writing the square root of 5 times 5. And from the square root of 5 times 5, that just means anything that shows up twice can get brought out. So that just becomes 5 right here. So that means we're left with 25 times 5, which equals 125. So these are some other radical rule, or square root and radical rules that you can be aware of right now. If you don't quite understand it just yet, that's okay. The main the main point were these first 3 slides where everything came out nice and even, because that's what you're going to be using for these next few lessons. But eventually we will get to this stuff, but just keep that in your back pocket. Okay, bye.